Oh, good morning. Hope you've got yours. All right, welcome. We are at Brookstone School and I am in Germany. Well, I'm in my room right now, but we're going to do a little bit of Algebra 2 while I'm gone and while you're getting ready for your quiz. Let's start with a few things that you might want to know to prepare. First, we're going to talk about patterns. First thing I want to discuss is how do you deal with a pattern and find the next case, the next number. Then we'll move on to how do you find the nth case, then maybe see if we can do some word problems. Let's get going. So let's say I give you a pattern. It's something like a sequence of numbers. Looks something like this. 2, 5, 8, 11. Let's first look at how do we find the next number. It comes down to finding the recursive pattern. In other words, what's happening each time. Each time. Notice I move my hand. Each time. So look at this here. Look at the fact that to go from 2 to 5 and from 5 to 8, there's a consistent pattern we're seeing. We're seeing that each time I'm adding 3. Adding 3. So if I wanted to go from 11 to the next number, I need to add 3 again. In this case, I'll have 14. That would be how I find the next number in that pattern. But there's something a little more that we want to do. We also want to be able to extrapolate. That's a big word for find out what happens a long way from now. What if we're interested in the nth case? What if we're interested in the 1000th case? I'm sure you and I don't want to go through all the numbers. So let's go back to this guy right here. Let's make a table. I'm going to start with the number n. Then I'm going to make a little function that outputs everything in this list. So I've got 1, 2, 3, 4. These are my indices. That's where mermaids live. And we've also got these numbers here, 2, 5, 8, 11, and so on. I'm seeing that I'm repeating addition here. I'm repeating addition. Repeated addition is, you're right, multiplication. Go ahead. We can pause the video if you're interested in thinking about that. So I've got something with multiplication here, 3 times each guy. 3 times n. Why do I say 3 times n? Because I'm multiplying by each step. How many steps? Okay, let's keep going. In other words, can I write 2 as something plus 3 times 1? Can I write 5 as something plus 3 times 2? Notice that this index matches this one in the list. So I'm just trying to find that pattern and see what happens here. Okay, well 2 is 3 plus what? Well, you're probably thinking -1. So I'm going to fill in a -1 right there. Is that consistent here? I'm using this to check my work. Is 5 -1 plus 3 times 2? I hope so. It sure is. I could continue this pattern forever if I like, but I'm just going to fill it into my little equation up here. So we've got this pattern that we've just deduced based on looking at the sequence, but now what if we're interested in something like the 14th case or the 1000th case? What we can do now with this explicit formula is we can plug in any number we like and find out what happens there. That's why I wrote to the nth case, any number you like. So for instance, if I want to know f of 500, I can just plug in 500 everywhere I see that n and evaluate this function. That would be -1 plus 3 times 500, or -1 plus 1500, or 14.99. Sounds like the price of something off an infomercial. Let's move on. Speaking of infomercials, let's talk about word problems. It's nice to be able to take a look at a word problem and take the information there and convert it into something with numbers. There we can do a lot more work than just thinking about it with words. So let's think about the time that you saw that Weird Al video and you sent it to 2 friends, and then they sent it to 2 friends, then their friends sent it to 2 more friends, and that pattern repeated, and that pattern repeated, and that pattern repeated, and that pattern repeated. How many people would have seen it at the end of 7 days? At the end of a week? How many people would have seen that Weird Al video? Well, let's start by making a little pattern here. So on the first day, you can see that, hey, we can make a little chart. There's N and there's F of N. The first day, you had 1 person that had seen it on really day 0, if you think of it that way. After 1 day, 2 people have seen it. After 2 days, 4 people have seen it. After 3 days, 8 people have seen it. After 4 days, 16. Now we're interested in 7. How many have seen it after a week? So let's look at what pattern is happening here. Notice we started with 1, and each time we repeated, not addition, but multiplication this time. Now you know a word for repeated multiplication. It's called an exponent. So let's use exponents. What's happening here? Repeatedly multiplying by 2. So that means we're taking 2 to that power of days. Does that match up? Is 2 to the 0 1? Yes. Is 2 to the 1 2? Yes, so it does look pretty good. It does match up. If I wanted to know how many people had seen that video after 7 days, I could plug in the number 7 and do 1 times 2 to the 7th, whatever that is. I want to say it's 128, but you can take the time to figure that out yourself. Let's be honest, no one wants to draw a tree with that many branches to really figure it all out. Okay, that would take much too long. Much better if we can use a formula a lot faster. I want to talk about a few things that you should know for the upcoming quiz. These are more definitions and review, but as the English department would say, you should know them like a poem. Know them all with feeling. Let's talk about the first few ideas. There are 2 ways to split up the real numbers. You recall the real numbers are anything I can write on the number line. There are rational numbers and irrational numbers. Now this doesn't mean some are good thinkers and some are crazy. This means is that some I can write as a ratio, like 2 over 3, and some I cannot. These numbers, like the square root of 2 or pi, confound attempts to write as a fraction. They also confound attempts to write them as a decimal that repeats or that stops. So those are 2 ways we can break up the rational numbers. Pardon me, the real numbers, we can break them up in 2 ways, as rational or irrational. Now inside this infinity of rational numbers, there are more special numbers we can also consider. These are the natural numbers and the integers. The natural numbers you learned in kindergarten, the counting numbers, 1, 2, 3, and so on. The integers are the natural numbers and their negative counterparts and 0. Think of the word integrity. These are numbers that are intact, just like whole numbers. So this includes numbers -2, -1, 0, 1, 2, so on and so forth. There are an infinity of these numbers that we could write, so obviously we don't have time to write all of them in the span of this video. When you find an infinite camcorder, let me know. We can talk about it. The next thing you should know are some of the properties of real numbers. These include the commutative property. We've all been on the morning commute that goes back and forth. This means we're talking about the fact that you can do A plus B, and that's the same as B plus A. It doesn't matter the order in which you do multiplication or addition. Multiplication and addition also have the associative property. In the same way that you might group with one group of associates, you could also group with another. So that same property for multiplication, for instance, says I could do multiplication with B and C first, then do A, or I can multiply A and B first and then do C. Cool thing about this property says that it doesn't matter when I'm adding or multiplying which one I do first. Okay, so that's one thing you should know. You should also know the distributor property. Now I mention this as its own thing because in some ways it unites multiplication and addition. What does it say? It says that if I've got a sum and I multiply it by something outside, I need to distribute that outside thing to each term in the list. What does that produce? AB plus AC. The last property I think you should know is that of the identity. There are two classic operations. They are addition and multiplication. Addition has an identity element. It's A plus, or it's 0, so A plus 0 is A. And multiplication has another identity element. You probably knew which one. It's 1. These are the numbers on which our whole number system is based. It's a little bit of what you should know. Like I said, know them like a poem, but also be able to look at numbers and identify where they fit in or what property is used. All right, gang. The last thing you should know for your quiz is about roots. No, I don't mean the mini-series, and no, I'm not referencing anything to do with hair. What I mean here is, how do you estimate square roots? Where are they on the number line? We said that they are on the number line. They are real numbers. It might be difficult to estimate them. Well, when I look at this guy with a square root, one thing I might want to do is think about square roots I do know. For instance, when I see 53, I think, hey, I know about the square root of 49. That's 7. That's a little less. I also know about the square root of 64. That's 8. So if I wanted to place this guy in the number line, I would know, in fact, he must be somewhere between 8 and 7. Now, we could even do a little bit better than that. Notice that 53 is closer to 49 than it is to 64. So if I wanted to reason a little better, if I drew out the number line, and I made 7 and 8 right there, I could probably guess that the square root of 53 is going to be closer to 7 than it would be to 8. It's a good technique to be able to reason about these roots that you may not know offhand, but could come up with some explanation for where they were. Well, notice we've gone through a few things. We've gone through finding patterns. We've gone through the definitions you need to know. We've also gone through a little problem on how to deal with square roots. Hope that helps you for your quiz. Study and study some more. Thanks.